a single source of light, monochromatic source of light. Monochromatic means only one color, monochromatic source of light. And from that, the wavefront is shown here, wavefront. Actually, wave is in the form of crest and trough. And here, the wave is represented, crest is represented by the dark lines, and the trough usually represented by dotted lines. So, for a point source, we know spherical wavefront will be emerged from it. And that, so through the slit, this slit, single slit, the wavefront is passing. And that wavefront is allowed to pass through two another small slits which are separated by a short distance for about 200 micrometer, like that. It's a small distance between the slits. Micrometer means it's minus 6 meter. Okay. So 200 micrometer. Okay. Such a small distance it is. So between the two slits. And then what happens when two slits are given here? Through both the slits, the waves will pass. The waves will pass through both the slits. And what happens after when from this slit the waves are passing, from this slit crest and trough like the waves are passing, and what will happen? Superposition of the waves take place. What is superposition? When the two crests or when the two troughs interfere, we get another crest, bigger one or bigger trough. And one crest and one trough interfere, we get minimum amplitude or minimum intensity. Like that. So here you can see some points. See some points they cross each other. Superposition is taking place. And we get the maximum intensity. If crest and trough are interfering, then we get minimum intensity. But you know, center point between, see, this is the center of the screen, so center point. Center point, when you take the waves coming from S1 and S2, take equal path. Length of the path is same. The distance from S1 to the center point and the distance from S2 to the center point, that distance is same. That means there is no path difference between the two waves coming from S1 and S2. Between the two waves coming from S1 and S2. So if path difference is 0, we get a bright fringe. And that condition is what we were deriving last class. Obtaining the condition for constructive and destructive interference. And if path difference is 2n minus 1 into lambda by 2, we get a minimum intensity. Minimum intensity. Crest and trough interfere. We get minimum intensity. And on the screen, this is the screen kept. On the screen, what you can see? You can see the bands or fringes. These are called fringes. On a screen, we can see fringes. Interference fringes, or you can call interference bands, BINDS, interference pattern on the screen. This is the pattern that we see on the screen. Center will be a bright one, then a minimum region. You see from here, this is bright one, again this part is minimum, and this part again bright region, like that. Alternate bright, dark, bright, dark. Like that, alternate bright and dark fringes are obtained on the screen. You see, if light would not have traveled like waves, we cannot see such pattern. For example, instead of these two single sources, if only one source of light is there, what you can see on the screen? Just a patch of uniform light distribution only you can see. If only one single source is there, what you can see? A uniform distribution. Just like when we switch on the tube light, we get light in our room. Just like that, on the screen you can see a color. For example, if it is green color is used, you can see green color. But if two sources are derived from that single source, they become coherent sources. See, this wavefront is divided here. Wavefront is divided here. So these two sources of light are derived from the single source. So they act as coherent sources. What is coherent source? Coherent source means a source of light having same wavelength, same frequency, and in same phase, or having a constant phase difference. So the best method is this dividing of a wavefront. As a Young's double slit experiment, we can see dividing a wavefront into two. So that means allowing them to pass through two slits. They act as coherent sources, and we get interference pattern on the screen. Understand? This is the interference pattern. So crust and crust interfere. What we get? Minimum or maximum? Crust and crust. Crust and crust of the wave interfere. What we get? Badra, what we get? Crust and crust interfere. What we get? Maximum density or minimum density?
Minimum.
Crust and crust ചെയ്യുമ്പോൾ മിനിമം ആണല്ലേ അതാണ് സൂപ്പർ പൊസിഷനിൽ പഠിപ്പിച്ചത് അല്ലേ
ഇല്ലല്ല
ആ രണ്ട് മാക്സിമം രണ്ടും ട്രഫ് ആണെങ്കിലോ
അതും മാക്സിമം
മാക്സിമം ആ ഒരു ക്രസ്റ്റും ഒരു ട്രഫ് ആവുമ്പോഴോ
മിനിമം
മിനിമം ആ അങ്ങനെയാണ് കേട്ടോ Okay, condition is what we were deriving last day. So I think you understood this experiment. What is the reason for this phenomena observed on the screen? Alternate dark and bright images are observed. Why? It is due to the superposition of the waves coming from two coherent source of light. So that way we can define interference. What is interference? It is the phenomenon of redistribution of light energy in a medium due to the superposition of the waves coming from two coherent sources. Okay. So it happens due to superposition of the waves coming from two coherent sources. That is very important. Okay. And this is, you can see another pattern here. See two slits, bright. See wavefront. These are wavefront. These lines are wavefront, spherical wavefront. If it is a linear source, we get a cylindrical wavefront. If it is a point source, we get point slit. We get a spherical wavefront. You can see the interference of the waves. And crust and trough. Maximum point. ഡോട്ടഡ് ലൈൻ മീറ്റ് ചെയ്യുന്നുണ്ട് രണ്ട് ഡാർക്ക് ലൈൻ മീറ്റ് ചെയ്യുന്നുണ്ട് ഡോട്ടഡ് ലൈൻ മീറ്റ് ചെയ്യുന്നുണ്ട് ഡാർക്ക് ലൈൻ അതായത് രണ്ട് ട്രഫാണ് ഡോട്ടഡ് ലൈൻ മീറ്റ് ചെയ്യുന്നത് ട്രഫാണ് ബോത്ത് ട്രഫ് സൂപ്പർ ഇമ്പോസ് ബോത്ത് ക്രസ്റ്റ് സൂപ്പർ ഇമ്പോസ് ഉണ്ടോ when we extend that line it meet at a point that is the maximum ഇനി ക്രസ്റ്റും ട്രഫും അതായത് ഒരു ഡോട്ടഡ് ലൈനും ഒരു മിനിമം കിട്ടുന്നിടത്ത് നോക്കുക കണ്ടോ ഒരു ഡോട്ടഡ് ലൈനും ഒരു ഡാർക്ക് ലൈനും മീറ്റ് ചെയ്യുന്ന പോയിന്റാണ് ഉണ്ടോ അങ്ങനെയുള്ള പോയിന്റ് മുഴുവൻ യോജിപ്പിച്ച് കഴിയുമ്പോൾ കിട്ടുന്നതാണ് മിനിമം ഇൻറ്റൻസിറ്റി ഒരു ക്രസ്റ്റും ഒരു ട്രഫും ഇന്റർഫെയർ ചെയ്യുന്ന പോയിന്റിലാണ് നമുക്ക് മിനിമം ഇൻറ്റൻസിറ്റി ഇനി രണ്ട് ക്രസ്റ്റ് ആണെങ്കിലും രണ്ട് ട്രഫ് ആണെങ്കിലും നമുക്ക് മാക്സിമം ഇൻറ്റൻസിറ്റി ആണ് കിട്ടുക രണ്ട് ക്രസ്റ്റ് ആണെങ്കിലും രണ്ട് ട്രഫ് ആണെങ്കിലും ഇത് രണ്ട് ക്രസ്റ്റ് മീറ്റ് ചെയ്യുന്നതാണ് രണ്ട് ട്രഫ് മീറ്റ് ചെയ്യുന്നതാണ് അപ്പം അങ്ങനെയുള്ള പോയിന്റ്സ് യോജിപ്പിച്ച് കഴിഞ്ഞാൽ നമുക്ക് മാക്സിമം ഇൻറ്റൻസിറ്റി ആണ് കിട്ടുക ഇതെന്താണ് ഒരു ട്രഫ് ഉണ്ട് ഒരു ക്രസ്റ്റ് ഉണ്ട് ഒരു ട്രഫും ക്രസ്റ്റും മീറ്റ് ചെയ്യുമ്പോൾ അവിടെ എന്താവും ഡെൻസിറ്റി മിനിമം ആവും അപ്പം സെൻട്രൽ വൺ എപ്പോഴും മാക്സിമം ആയിരിക്കും കാരണം എന്താ പാത്ത് ഡിഫറൻസ് 0 ആണ് ദ വേവ്സ് കമ്മിങ് ഫ്രം S1 ടു ദിസ് പോയിന്റ് ആൻഡ് ദ വേവ്സ് കമ്മിങ് ഫ്രം S2 ടു ദിസ് പോയിന്റ് ദ സെയിം പാത്ത് സോ പാത്ത് ഡിഫറൻസ് is 0 therefore we get maximum density. That condition is what we are deriving last time. So interference can be explained only based on the wave theory of light. And you can on the screen you can see bright, dark, like that fringes can be seen on the screen. So this is interference I explained last class. Condition for constructive and destructive interference. This is what we have done last. R equal to amplitude of the resultant wave, R equal to root of a square plus 2ab plus cos y plus b square. That is what we got last class. Then, but R square equal to a square plus b square plus 2ab cos y, we got. Then intensity of a wave is directly proportional to square of the amplitude. Intensity is related to the amplitude, intensity of light on the screen. I told you maximum intensity, minimum intensity are observed on the screen. That intensity is directly proportional to square of the amplitude. Understand? So we can write this equation. R square is taken as resultant intensity. R square. Resultant wave's amplitude is this. So the resultant wave's intensity I is equal to A means amplitude of the first wave. So A square is intensity of A is amplitude of the first wave. So its square will be intensity of the first wave. B is amplitude of the second wave. Its square will be its intensity, second wave's intensity, E2, I2. Then 2 into A into B. So A into B can be written as root of I1, I2. Then cos y. Cos y is equal. So this equation, this is in terms of amplitude and this is in terms of intensity. So resultant intensity of the wave when after superposition, the resultant intensity of the wave I is equal to I1 plus I2 plus 2 root I1 I2 cos phi, where I1 is proportional to A square, I2 is proportional to B square and I is proportional to R square. For constructive interference, I should be maximum. So after obtaining this condition, for constructive interference, I intensity must be maximum. Constructive maximum intensity, max amplitude will be maximum, intensity will be maximum. So I should be maximum. From this equation, when I becomes maximum, for which angle of I becomes maximum? Devananda tell. For which angle of phi this intensity maximum? Devananda. Devananda ഇല്ലേ മഞ്ജിമ Devananda ഉണ്ടല്ലോ പറ which angle of phi we get maximum intensity?
0.
Very good. One is that 0. Other values tell 0. After that next phi equal to pi ആണോ പൈക്ക് മൈനസ് വരില്ലേ pi ആണോ 2 pi ആണോ
2 pi 4 pi
4 pi കറക്റ്റ് 0 2 pi 4 pi അതിനൊക്കെയാണ് നമുക്ക് മാക്സിമം വാല്യൂ അതായത് കോസ് 0 2 pi 4 pi നൊക്കെ 1 കോസ് 1 ആണ് 2 pi 4 pi നൊക്കെ 1 വരും അപ്പോൾ മാക്സിമം ഇന്റൻസിറ്റി ഏതൊക്കെ വാല്യൂലാണ് phi ഈക്വൽ ടു 0 2 pi 4 pi എക്സെട്ര അപ്പോൾ phi നമുക്ക് എഴുതാം phi ഈക്വൽ ടു 2 and pi equal to E1 integral multiple of pi. About phi equal to 2 and pi, we get maximum intensity. So what is the condition? Condition for interference, constructive interference, phase difference between the two waves equal to 2 and pi, where n equal to 0, 1, 2. Here you see n equal to 0 you have to give because center, that is central bright fringe. And first bright fringe, second bright fringe. So in terms of phase difference, what's the condition? The two waves should have a phase difference of 0, 2 pi, 4 pi, etc. Or you can write pi equal to 2 and pi, where n equal to 0, 1, 2, because 0 is for the central bright fringe. Okay. Then in terms of path difference also you should be able to tell condition. Same thing. This is in terms of phase difference. So in terms of path difference, what is the condition? The same thing we are expressing in terms of path difference. This is in terms of phase difference. This is V1 integral multiple of pi. Then if x is the path difference between the two waves, suppose x is the path difference between the two waves reaching the point P corresponding to the phase difference of phi. And there is a relation connecting path difference and phase difference. For example, you can see in this figure, this is one wave, crust, maximum density upward trough. One wave is shown here, and here this is the wavelength of the wave, distance between two crusts, distance between two troughs. That is actually the wavelength, or here to here, that is one wavelength. And for that, what is the phase difference? 0, and here it is pi by 2, here it is pi, 3 pi by 2, and 2 pi. So one wavelength corresponds to 2 pi radian. One wavelength corresponds to 2 pi radian. So 2 pi phase difference, what is the path difference? Lambda. 2 pi phase difference, what is the path difference? Lambda. Yes?
Jag vill vara redovisad in den.
Okay.
Det är som en motgång.
Okay, see, so what we have seen here, for a phase difference of 2 pi, the path difference corresponds to lambda. And for unit phase difference, for unit phase difference, 2 pi is changed to 1 unit phase difference. What is the path difference? Lambda by 2 pi. We just divide by 2 pi. Here also divide by 2 pi, here also divide by 2 pi. So 2 pi phase difference, lambda path difference. For unit phase difference, lambda by 2 pi. Therefore, for a phase difference of phi, what is the path difference? Lambda by 2 pi into phi. Phi phase difference, what is the path difference? Lambda by 2 pi into phi. So you just substitute that path difference equal to lambda by 2 pi into phi. Phi value you substitute 2 and pi. 2 pi cancel, we get n lambda. So path difference is n lambda, we get a bright fringe. So now we got the condition for constructive interference. When phase difference is 2 n pi or path difference is n lambda, we get a bright fringe. Okay, the path difference between the two waves is n lambda, integral multiple of lambda. We get a bright fringe. Path difference is 0. When n equal to 0, path difference becomes 0. Central bright fringe we get. That is a constructive interference take place. And the next condition for destructive. Oh no, this is written in words. In words it is written. This is equation, this is written in words. Destructive. For destructive interference, what is the condition? I equation we know. I is equal to I1 plus I2 plus 2 root I1 I2 cos phi. We got. So when phase difference is pi, I apply minima. In that I will show you the equation. This equation. See, I1 plus I2 plus 2 root I1 I2 cos phi. In this equation, when I is minimum, what are the values? Accidental. And what is the condition for minimum interference or destructive interference? Pi equal to? Pi equal to?
Pi.
Pi. Next value?
3 pi.
3 pi. 5.
And 5.
Pi, 3 pi. The odd integral multiple of pi. Odd integral. Pi, 3 pi, 5 pi, 7 pi, like that. Odd integral multiple of pi, when we take pi, take that value, odd integral multiple of pi, we get minimum intensity. That is destructive interference take place. Okay. Pi, 3 pi, 5 pi. Or see here we have written phi equal to 2 and minus 1 into pi, because we have already taken n equal to 0. That's why. If we are taking n as 1, we can write plus 1. But we have already taken n is 0, central bright fringe. We get, as n is taken 0, when n equal to 0, what we get? 2 into 0, 2 minus 1 into pi. So that is minus pi. When n equal to 1, here we take n equal to 1, 2. N equal to 1, 2. Where 2 into 1, 2, 2 minus 1, 1, pi. First value t, pi ut. N equal to 2, 2 into 2, 4, 4 minus 3, 3 pi. So n equal to this equation is written. These equations are very important for doing problems and all. So when phi equal to 2n minus 1 into pi, we get destructive interference. Then what is the path difference? We already got the equation for finding the path difference. X equal to, always remember this equation. X equal to lambda by 2 pi into phi. That is the relation connecting path difference and phase difference. X equal to lambda by 2 pi into phi. Lambda by 2 pi, what is pi? 2n minus 1 into pi. Pi and pi get cancelled. We get 2n minus 1 into lambda by 2. So, condition for path difference we got. 2n minus, if the path difference between the two waves coming from the two slits and reaching the point P is 2n minus 1 into lambda by 2, we get a minimum intensity. Destructive interference take place, we get minimum intensity. In terms of phase difference, what you can tell? If the phase difference between the two waves is odd integral multiple of pi, we get destructive interference or minimum intensity. That is written in words. And you can see the notes. So we already derived the condition for constructive and destructive interference, very important. Note, when interference is constructive, cos phi equal to 1, then what is amplitude? R equal to root of a square plus b square plus 2ab cos phi is 1. But 2ab into 1, 2ab. So we can write a root of a plus b whole square. What is it? Root of a plus b whole square. That is a plus b. So the maximum, when interference is constructive, the amplitude is maximum. It will be sum of the amplitude of the two individual waves. Sum of the, see, one crest, second one's crest, superimpose, we get a greater crest. Sum of the amplitudes of the individual waves, maximum amplitude is the equation for maximum amplitude, A plus B. Then I max is proportional to square of the amplitude, maximum intensity. So I max is proportional to A plus B whole square. A plus B, you got R max equal to plus B. So A plus B whole square. Therefore, I max is equal to K into A plus B whole square. Equation I max. If R max is got, we can R square will give I max. Okay. When interference is destructive, cos phi is minus 1. So we get R equal to root of A square plus B square minus 2AB. Cos phi is minus 1. So R equal to A root of A minus B whole square, that's equal to A minus B. So what we get? Difference of amplitude of the two waves. So in the case of destructive interference, what is the resultant amplitude? It will be minimum and it will be the difference of the amplitude of the two waves. We know both the waves are, if they are having same amplitude, what will be the intensity? A equal to B equal intensity and down. R will be A minus B, A minus A 0. Intensity of 0. If both are having same amplitude, both the waves are having same amplitude, resultant amplitude is the difference of the amplitude of the two waves. So same quantity when we subtract, we get 0. So intensity becomes 0. So intensity minimum equation is K into A minus B whole square. So this is the important equation. I max by I minimum equal to A plus B whole square by A minus B whole square. All these equations are very, very important. When B equal to A, that is what I told, when amplitudes are equal, both the waves are having same amplitude. What is R max? A plus B. A plus A, 2A. What is R minimum? A minus B. A minus A, 0. maximum intensity and minimum intensity. The maximum is having its maximum value, but minimum is zero value. So when both are equal amplitude, both the waves are equal amplitude, the contrast between bright and dark fringes will be very good contrast we get between the bright and dark. So that is when two waves are having same amplitude. So dark fringes will be perfectly dark, and the contrast between bright and dark interference fringes will be best. Best contrast is obtained when both the waves are having same amplitude. Okay. Then one equation for doing this, from this equation problems usually ask. So another note is IR equal to I1 plus I2 plus 2 root I1 I2 cos y is outside the root. Please take note that. So if I1 equal to, if both sources are having same intensity, I1 equal to I2, let us take I0, that is I1 equal to I2 equal to I0. Both are having same intensity, both the light source. Then IR, resultant intensity, will be I0 plus I0 plus 2 into root of I0 into I0 is I0 square cos phi. So 2I0 plus 2I0 cos phi. So 2I0 is taken outside the common factor, it is taken outside the bracket into 1 plus cos phi. 2I0 into, this is written as 2 cos square phi by 2. So the steps, how you got this step that I have explained here. 1 plus cos y is 2 into cos square phi by 2. Mathematics students, you are, so you will be knowing sin cos square theta plus sin square theta equal to, is there any direct equation for this? Have you studied, children? പഠിച്ചിട്ടുണ്ടോ അങ്ങനെ ഡയറക്റ്റ് ഇക്വേഷൻ പഠിച്ചിട്ടുണ്ടോ? നമ്രത ഡയറക്റ്റ് ഇക്വേഷൻ പഠിച്ചിട്ടുണ്ടോ? ഇങ്ങനെ 1 plus cos y ഇങ്ങനെ പഠിച്ചിട്ടുണ്ടോ? ഇല്ല അല്ലേ? മാത്സില് ഉണ്ടോ ഇല്ലേ?
2 cos square
phi by 2, 1 plus cos phi equal to 2 cos square phi by 2 പഠിച്ചിട്ടുണ്ടോ? ഇല്ലേ? ടീച്ചർ എക്സ്പ്ലെയിൻ ചെയ്യാം. Cos square phi plus sin square phi equal to 1. We know cos of a plus b equal to cos a cos b minus sin a sin. അപ്പോൾ a equal to b ആണ് നമ്മൾ പറഞ്ഞത്. അപ്പോൾ phi plus phi വരും. cos a എന്ന് പറഞ്ഞാൽ phi തീറ്റ അല്ല phi. cos phi into cos phi minus sin phi into sin phi. So cos 2 phi equal to cos square phi minus sin square phi. Therefore sin square phi equal to 1 minus cos square phi from equation 1 from this. Sin square phi equal to 1 minus cos square phi, and put 3 in 2. 3 in 2. So cos 2 phi is equal to cos square phi minus of 1 minus cos square phi. So cos square phi minus 1 plus cos square phi. So 2 cos square phi minus 1. Cos 2 phi equal. Therefore 2 cos square phi equal to 1 plus cos 2 phi. If phi equal to phi by 2, then what you can write? Phi equal to 2 cos square phi by 2 equal to 1 plus cos phi. 1 plus cos phi equal to 2 cos square phi by 2. That is written here. So for doing problem, you have to remember this equation. If both the sources are having same intensity, what is the resultant intensity? If you know this formula, you can calculate it easily. Otherwise, you have to go through all these steps. Just to remember this formula. Resultant intensity is 4I0 cos square phi by 2. 4I0 cos square phi by 2. Okay. So that is for doing problems. Condition for sustained interference. A pattern in which maxima and minima on the screen do not change with time is called sustained interference pattern. So I showed you first that in that figure, Young's double slit experiment, I showed you the figure that green colors, black color, like but that you can see that's a sustained interference pattern. Pattern is not changing with time. Such a pattern is called sustained interference pattern. And to get such a pattern, what should be the conditions? Two sources should emit waves of same frequency, same wavelength. That means they must be coherent. The two light sources should be coherent. So, see, in our room, we cannot perform such experiment. We have to maintain such condition. The slit width must be very small, about 200 or 300 micrometer. Screen should be at a distance of 1 meter or 2 meter from the screen. Such laser beams will be used. Like that, I send you one video. In that, one scientist is doing that experiment. So he is explaining that the same condition he is using. So we get a sustained interference pattern on the screen. Two sources should emit waves of the same frequency, same wavelength. Two light sources should be coherent. For better contrast, amplitude should be equal. Both the waves come from the same source, they will have the same amplitude. So we get a better contrast. Bright and dark. Bright will be very bright. Dark will be completely dark. So we get a very good contrast. The source should be narrow, just like a laser beam. Narrow and emit waves in the same direction. The distance between the source and source are small. Two slits must be very small distance apart. And source and screen is large. Distance between the source and source are small and screen is placed at a large distance. The distance between slit are very small and the distance between slit and the screen are at a large distance. For example, when the distance between the two slits is very small, about 200 micrometer, but the distance between the slit and the screen is about 2 meter like that. That's a long distance. Then only this pattern will be observed. Interference and energy conservation. You see, in interference pattern, what we are seeing? Alternate bright and dark fringes are seen. Do you think that intense part, where does this light come from? Where does this light come from? At one region, intensity is maximum. From where it got that intensity? We know energy can neither be created nor be destroyed. Then what happened? That is, the energy is at dark part and intensity is lost and it is gained at the bright part. So constructive interference, there is gain in energy, light energy. Intensity is maximum. So where the energy is lost, that is gained in the bright part. At the destructive part, interference takes place, energy is lost, but it is gained at the constructive interference. So that we are showing with the equations here. Interference is according to the energy conservation. In interference pattern, maximum intensity we know K into A plus D whole square. Minimum intensity is K into A minus D whole square. And average, when you take average of this, we get I average equal to I maximum plus I minimum by 2. So we have to divide this and expand this. And when we divide, we get K into 2 into A square plus B square by 2. 2 get cancelled, we get K into A square plus B square. This is the average intensity. When interference takes place, intensity one part is more, intensity other part is less. And when we take the average intensity, we get K into A square plus B square. And if the interference is not taking place, what will be the average intensity? Let us see. If there were no interference, intensity of light from the two sources at every point on the screen would